Hi everyone! So today in this video you're going to be learning about section 1.2, which is on linear measure. Before I get into that, I do want to talk about lines from yesterday. So yesterday we talked about lines, right? You watched videos on points, lines, and planes. So when you have a line, you are writing it as A, B with the bar on top with arrows on both ends, right? That's is the notation for a line. So now we're going to talk about the notation for a line segment. So here I have a line segment. A line segment is a measurable part of a line that consists of 2 points, and those 2 points are called endpoints. Okay? And it will consist of all of the points in between them. So a line has infinitely many points. You don't need to draw all the points. We're only going to have a couple of them on there. In this case, we'll just have 2. So I'm going to label it as A, B. When I write that in notation, I will have 2 uppercase letters, A, B, with just a bar above it. And that is a line segment. Over here is the segment length. So this is talking about that distance, so a measurable length, so something in inches, centimeters. And so let's say here we have the segment AB. So I'm taking it from this guy over here. So segment AB has the length of AB. Well, wait a second. That's kind of confusing. But if you think about it, I did 2 things different here. I have here AB with a bar on top. This is talking about the picture. When you have AB or 2 letters representing a segment, that is going to represent the size. Okay, so when there's nothing above it, that is going to talk about the size. We are going to talk about betweenness. So as it sounds like, betweenness is when you have 2 things and in between them, there's something else. So here it's for any 2 points, A and B. So I'm going to draw a segment. Oh, that is too skinny there. So I'm going to draw a segment, AB, and then in between it, there is going to be a point C. Now, when you see IFF, that means if and only if. So if and only if A, B, and C are collinear, so they're in a straight line. So let's say that we said that AC was 2 inches and CB was 3 inches. That means the length of AB will equal 5 inches. Then we have over here congruent segments. So congruent is an equal sign with a squiggly above it. So when we're going to go ahead and talk about congruent segments, that is segments with the same exact measure. So let's draw an example here. So let's say we have RS has the, and I don't actually like the S because it looks like a 5. So I'm going to do RT, and it has a distance of 5 inches. Then we have over here PQ has the distance of 5 inches. Well, we know that RT is equal to 5 inches. We also know that PQ is equal to 5 inches. So that means we can say that RT is equal to PQ. Okay, that is called transitive property, which we will talk about more later on. And then since we can say that their measures are equal, we know that their segments are going to be congruent. Okay, and notice the notation. I went from the line, the measure. Actually, I will say here the length. So this is the size, and this is talking about that picture. Okay, so then tick marks is a way to show that things are congruent. So let's say here we have 2 segments. Okay. Line L and line M. I'm sorry, segment L and segment M. If you put a tick mark in between there, it will represent that those 2 are congruent. We can have another one over here. Here's this nice and long segment, but this segment for line N has 2 tick marks. It is not congruent to these two over here. So make sure you're taking notice of those tick marks. Then we have here rays, which we have talked about. So a ray will have an endpoint, and then on one side of it, there will be an arrow going in one direction. Now, notice a ray, yes, is still a line. So we still have to go ahead and have 2 points on that line. So here we'll have R, and let's put a point Q. Now, the way to write that notation would be RQ, and because of the way the ray is going, you still have to write it in that manner. So the R is where the endpoint is. That means it needs to still be in that exact place. It will not work if you put QR. That is not true. That is false. So that would not be a correct way to write a ray. Then we have opposite rays. So here I'm going to go ahead and write an example. So I'm going to go ahead and draw ourselves just a lovely line. I'm going to put 3 points, and I'll just do A, B, and C. So here we have opposite rays, B, A, and B, C. Okay, so what does that look like? Here we have B, A is going in this direction. So we're going to have B next to the endpoint. Then we have here B, C. B is by the end, is at where the endpoint is. So we're going to have that first, and then it goes to C. You will not switch the order of when you write the bar on top with the arrow going in the one direction. It's always going to go in the direction to the right. Alrighty, so then we have some examples. So we're going to do a couple quick examples. So over here in this one, we are just going to finish this congruent statement. So it's saying that segment AC, so segment AC, this guy here, is congruent to what? Well, this is 6 inches, and I notice that this is 6 inches. So segment AC is congruent to segment BD. You can also write segment DB. BD or DB, either one is fine. Next over here, this one just has tick marks. So we notice that segment RS has 2 tick marks, and segment TU also has 2 tick marks. So then we'll have here TU with the segment above it, or you can write UT. Next, then we have SU, so we can either write RT or TR. Alrighty, over here we're going to do a couple examples about betweenness. So over looking at these, we have RS equals 12, ST equals 19, and RT equals 31. This is the longest. So I know that if I draw a segment here, we got our 2 points, we'll have an R and a T. This distance says that it's 31. So then looking here, we use the R, we use the T, so you can check those off. We use the R, we use the T. Left over, we have the S. So I know the S is going to be somewhere in the middle. Over here, RS is 12, and then ST is 19. You add those up, and it equals 31. So we can say S is between RT, and you can also write it as TR. The order does not matter. So the next few examples are very similar in that manner. But then this last one here, I do want to reference. So this is the longest one, right? That's the biggest number. So I'm going to draw a segment. So we have K and then H, and then the last letter would be D. And then we have here that KH is 20, and that DK is 9, and DH is 15. 9 plus 15 does not equal 20. So 9 plus 15 does not equal 20. So this is not true. So these points are not collinear. Alrighty, and that is it for the section 1.2 notes. I hope you have a great day.